So the first ever level of measurement called the nominal scale, and as we discussed earlier, what type of statistics can we use? And you need not to remember actually all of these, what we can and what we cannot. When the time would come when you would start collecting your data, and when you would have your data in your hand, and then you would see that this data is actually comprised of several nominal, ordinal, interval, and ratio scale measurements, and then you have to apply different type of statistics on different type of scales you had already previously collected. For example, what type of statistics can you use if you collect gender data, if you country of origin data, or nominal scale data? It's only frequency, distribution, and mode. For example, how many females are there in a class, how many males are there in a class? We could only use their numbers. And who is at the most is actually mode. Maybe you are very well aware of this mean, median, mode. And then we cannot divide, we cannot subtract, we cannot use mean, averages, or any other statistical analysis for nominal scales. So this is very basic, very first ever level of measurement for anything if we are measuring in our surroundings. The second level of measurement is little bit advanced, little bit better, little bit superior than the first one. The first one, as being said, the nominal scale, and the second one is called the ordinal scale. The ordinal scale, as we remember, as you could recall the name NOIR, NOAA. The second character of the NOAA is O. O for stands for the ordinal scale. These are actually distinct classes, but these classes have a natural ordering or ranking. Natural ordering or ranking. The differences can be ordered on the basis of magnitude, on the basis of superiority, on the basis of who's better, who's not better. For example, final position of horses in a thoroughbred race is an ordinal variable. Ordinal, as the name indicates, is from order. The horses finish first, second, third, fourth, and so on. The difference between first and second is not necessarily equivalent to the difference between second and third, or between third and fourth, which actually means there is some order. For example, in a class of student who there are 5 students, and one student stood first and the second, and then there's a third at place, and fourth and fifth and sixth. But the difference between first and second is not exactly the same as third and fourth. This is an example on a scale, on a graph. So ordinal scale does not assume that the intervals between members are equal. For example, finishing place in a race, first place, second place, and third place. For example, this is the first place, this is the second place, this is the third place, and this is the fourth place. As we could see, the distance between first place who finishes the race and the second place who finishes the race is not the same equal. Hence, we call it ordinal scale. Ordinal scale have some orders. For example, you have been watching FIFA World Cup. One country, they took the trophy, they took the World Cup, and then there were countries who were second and third and fourth and fifth. All these things are called ordered. For example, things in a priority. For example, things in a list, which something if is at second place, we could say this thing has less priority as compared to the first place. If something is third place, which means this thing has less priority than the second place, but better than the fourth place. However, the distance between first place, second, third, or fourth is not equally same. Like we have the distance between 1 hour or 2 hour is exactly the same. The distance between 2 hours or 3 hours is exactly the same, and the so on and the so forth. So again, we would have an activity to test your knowledge. So can you think of any ordinal variable which has some type of an orders? Order in the form of superiority, not inferiority, we could say, but in the form of who is the first, the second, the third, or the fourth. So can someone come up with an variable which is in ordinal form?
Sir, I think can we say the classes like fifth class, sixth class,
Yes,
seven class.
exactly. When you're studying from class 1 to class 10 or class 1 to class 5 or some undergraduate to
These
graduate
are
levels,
ordinal.
this these are the ordinals. So what statistics can you use actually when you have the ordinal data? So here you can use the frequency distribution, which was exactly the same when you were doing the nominal data. However, you can also use the median and percentiles for the order data. However, we cannot add or subtract. We cannot divide them. We cannot multiply them. We cannot use averages. We cannot use ratio or coefficient of variations. Such statistics cannot be used for order data. Even social sciences or even in marketing and businesses, when you are going to ask someone how likely are you going to buy this product, for example, very likely to less likely, these are orders from highly agreed to highly disagreed, and these are all ordered data. So the third one in the low level of measurement is the interval scale, and this is very easy for you to understand because there is only one thing so far around the world which we could see best fit in the interval scales, and this is called the temperature. So let me explain what is interval scales. It is possible to compare differences in magnitude, but importantly, the 0 point does not have a natural meaning. It captures the properties of nominal and ordinal scale used by most of the psychological tests, designates an equal interval altering the distance between, for example, temperature 1 and temperature 2 is the same as the distance between A4 and A5. So only the temperature is measured on interval scales. And the difference between interval and ratio scale is exactly the same. Because when we say the temperature is zero, does this zero mean something or does this zero mean nothing? It actually makes the difference because in the temperature, when we say there is a zero temperature, we cannot say nothingness of a temperature. There is no temperature. No, there is a temperature, and then temperature is measured on at the moment is zero. However, when someone asks you how much is your salary or how much you earn, you say zero. This means you are earning nothing. So that is the only difference between interval scales and ratio scales, because the ratio scale, when it has zero, this zero identifies nothing. Then let's discuss about the ratio scale, which is the last one, and this is the best one because most precise things are measured on ratio scales. For example, age in years, for example, height, for example, weight, for example, the distance, for example, the intensity of the light, for example, the pressure of the air, pressure of the water, pressure of the gas, pressure of the atmospheric pressure, and so many things we're measuring on these ratio scales. And these ratio scales are considered as the most refined and most precise scale of measurement. Ratio scale captures the properties of the other types of scales, which means it has the properties of nominal and ordinal and interval scales as well, but also contain the true zero. Like in the previous example, we had temperature. Temperature is measured on interval scales, and interval scale does not have a true zero because there zero means the temperature, zero means does not mean there is no temperature at all. But here in this ratio scale, for example, if I say how many kilometers do you walk? If you say zero, which means you do not walk at all. So the walk measured in kilometers is called the ratio scale. So this zero represents the absence of the quality being measured. There is nothing at all. For example, heartbeats per minute has a very natural 0 point. Zero means no heartbeats. Weight in grams is also a ratio variable. Again, the zero value is meaningful. The 0 grams means the absence of weight. There are two types which you shouldn't be very much worried about at the moment: discrete and continuous. Discrete is an exact number in a ratio scale, and continuous is an infinite values between 1 and 2. For example, discrete is, we could say, 1, 2, 3, 4, 5, and 6. And continuous, we could say there are multiple or infinite values between 1 and 2, like 1.213 or 1.456 7876.
Sorry, इसको डिजिटल और एनालॉग भी कह सकते हैं, जैसे डिजिटल जो होता है वो
Yes, you can say, for example, the clock, digital analog could be, maybe you're right. For example, the digital clock, it tells us the time in seconds. For example, what is the time? 3:52 and 32 seconds. It cannot say 32.89 seconds. No, it cannot tell you this. So one example maybe is the digital analog, but in other example, I have two examples here. For example, the number of siblings a person have is a discrete. For example, you have two siblings, three siblings. You cannot say I have 4.5 siblings. Can you say I have 3.8 sisters and brothers? No, you cannot say it. It has to be a fixed number. So 0 means literally none, and a person who has four siblings had twice as many as someone who had two siblings. But no one can say I have 3.7 siblings. So this is a discrete number. This number of persons, number of countries around the world. This is called discrete. So the other one is called the continuous. For example, a salary a person gets every month is called a continuous variable. A person who have dollar 4,600 a month has twice as much as someone who had dollar 2,300 a month. So this is the amount of salary a person is getting, but this could be 4,600.2345. You're not exactly getting the same amount. So we would had one more activity where I would ask you a couple of questions in which you are supposed to tell me one variable. Maybe it can be discrete or continuous, but you have to tell me one variable which is on a ratio scale. Asad Khan, this is your time now.